Okay, in this video we're going to go over how to write, including units, and then interpret the slope of a linear model. So the idea here is that if we're given a linear model, the slope of the model always represents the rate of change of the thing that's being modeled. So for this example, we have a linear function that is estimating air temperature in degrees Fahrenheit as a function of cricket chirp rate. So T represents air temperature, cricket chirp rate, R, represents the rate in chirps per minute at which a cricket is chirping. And what's been discovered is that the warmer it is, the faster the crickets will chirp. So you can estimate air temperature by counting cricket chirps. And what we want to remember for this particular example is that the slope of a line M is always going to be the change in the output variable, or the dependent variable, divided by the change in the input variable, otherwise known as the independent variable. So it's always going to be delta output over delta input. So for this particular model, the outputs are temperatures in Fahrenheit, and the inputs are cricket chirp rates in chirps per minute. So the delta output will need to be delta T, the outputs are T's, divided by delta inputs, but the inputs are cricket chirp rates, which we represent here with an R, so it's going to be delta T divided by delta R. So now we look at the slope of the line, which is 13 over 60, so the 13 has to be the delta T. The 60 must be the delta R. So I'm going to write the slope, 13 over 60, but I recognize that the 13 is a delta T, which is a change in temperature, which is being measured in degrees Fahrenheit. So this 13 is really 13 degrees Fahrenheit, and the 60, which is delta R, is really the change in cricket chirp rate. So this is 60 chirps per minute. So there's the slope of the line, including units, 13 degrees Fahrenheit over 60 chirps per minute. So I've done the first part. I wrote, including units, the slope. Now I need to do the second part, which is interpret that slope. And this is why writing the units are so important. Writing the units is what allows us to interpret the slope. So I want to interpret it by reading the change in input first, and then identifying what that change in input is doing to the outputs. So the 60 here is indicating that an increase of 60 chirps per minute, and I know it's an increase because the 60 is positive, indicates, what does it indicate? Well, it indicates the change in the numerator. Indicates an increase of 13 degrees Fahrenheit in the air temperature. Or we could say that for every increase of 60 chirps per minute, we expect a corresponding increase in air temperature of 13 degrees Fahrenheit. Next example, this is the boiling temperature of water. So the temperature at which water boils is a function of elevation. The higher one goes, the lower the temperature needed to boil water. The boiling temperature of water, T, in degrees Fahrenheit, as a function of elevation A in feet, is modeled by the linear function temperature as a function of elevation or altitude is equal to negative 0.0036 times A plus 212. So again, the slope of this line is sitting right here, negative 0.0036, and what we want to recall is the same thing that we just talked about, that the slope of a line is going to be given by the change in the output variable, and in this case the outputs are temperatures, divided by the change in the input variable, and in this case the input variable is given by elevation in feet. So delta A, we're using A for altitude to represent elevation. So now I look at the slope and I get the number. The number is negative 0.0036. But I recognize from here I need delta T over delta A. I need change in output divided by change in input. So I can take this number and just write it as a fraction over 1. And then I write down what the two numbers represent. The numerator is delta temperature. So this is being measured in degrees Fahrenheit. And the numerator is delta altitude or elevation. So this 1 represents 1 foot. So now I've written the slope including units. I've written the slope including units. Now I'm ready to interpret that slope. So again, I start with the input variable and I write what the input variable is causing. A 1 foot, a 1 foot increase in elevation causes the change in the input, causes the change in the output, causes a negative 0.0036 degree Fahrenheit change in the boiling temperature of water. And I could have done this a little bit differently. This negative sign right here, we recognize that's a decrease in temperature, so I could have chosen to not put the negative sign and instead say that a 1 foot increase in elevation causes a 0.0036 degree Fahrenheit decrease in the boiling temperature of water. So I could have gotten rid of the negative sign and replaced it with the word decrease, which indicates that we had a negative number to begin with. A decrease in the boiling temperature of water.